我待会要讲台语了。大家好。It's always my great pleasure and honor to be here to join the symposium as always. And today I pick a very simple, uh, um, titles that most scientists that pursue almost all their lives and try to define an equation. And right now, it's an AI models that people try to find, and that can explain everything. And so before I start, I would like to introduce our company. Our company is called Quanta. Quanta is a company that makes a huge amount of computer. Computer, of course, is not AI, but without computer, there is no AI. So the company is a Fortune 500 company, and we move from different kind of transformations. And actually, MIT CSAIL has played a very important role and to help and to guide and Quanta into different kind of stage, from mobile computing, cloud computing, and right now to AI. And so we have also collaborate, in addition to CSAIL, we collaborate with Media Lab and Wandetta Pachal and other, great products. And this is the Wandetta project, Pachal projects that we have done to support the education of the third world. And also, following that, we started to, before year 2000, we only had one product called laptop. And in year 1999, we became world number one in laptop manufacturing. And in year 2000, we started to think about, what we should do for the future computing world. So we started to, work with professors like Srini and also Michael Detouzes. At that time, the most important project in MIT is actually, oxygen. And so we started to move all our efforts to the cloud. We do everything inside the cloud, all kind of server. And in addition to server, we also work on robotics. And for collaborative robotics, we are world number 2 in terms of shipments. And right now, one of our efforts is that we back to humans. We develop different kind of sensors, and we try to collect more data, and using the data to do machine learning, and we try to do more smart medicine applications, based on the data we collected. And of course, there are many things like security, privacy of the data and data governance, and how to pick up the right models, how to provision the models as a new services for the future precision medical care. And that's one of our focus right now. And my team is, of course, is very focused on the design. So we received many product design awards. Usually, a pure contract manufacturing company or ODM companies, they don't really focus on the product design because product design is actually come from your customers. But if you want to do something new, then you have to consider how to package all the user experience as an offering to your customer. And so we are making all kind of things, not just hardware. We are enabling, for example, hospital professional care over the cloud and over different kind of inferencing model AI to the home. And so back to what I'm going to speak today, and basically, before AI and 100 years ago, and basically people started to think about the future under the apple trees. And you can see that, just like Srini told me yesterday that his daughter majored in pure mathematics. So for mathematicians, they play with pencil and paper. There is no computer, only pencil and paper and theory. And they try to use pencil and paper to understand the world, to develop equations that can possibly describe everything. So you can see that, that for hundreds of years, we are played of equations like Einstein and also like, Schrödinger and also the Richard Feynman's and even, Stephen Hawking's. So even now, we are using the simple equation or governing equations and based on the physical theory and to describe the physical systems. And based on that, we develop different kind of systems for that. That's our industry now. But the industry future will be different. It's not only the equation. We have new new systems or new methodology to describe the physical worlds, which is AI models. But you can also see that hundreds of years we have different kind of shoulders that we can use, and we can stand on top of it to create a future. But what about now? So the world is changing, quite fast. Early this year, of course, this is a quest, eternal quest. And you can see that 2 years ago that we have ChatGPT. So you have any questions, you don't need to, study from the bottom. You simply ask ChatGPT the questions, then you can get the answer. You can always get the answer, but the answer won't guarantee always right. And the second thing is that, early this year, you saw that a very beautiful lady is walking on the street, and it's all generated by text. So the project is called Sora. Sora means sky or Kong, which means that there is no limitations of this technology. So what they really try to do is that, quite interestingly, that OpenAI announced in their website that they try to build a video generator, AI generator models that can describe the physical world. And actually, this is fully in line of what we are trying to do in the scientific revolutions. And so the difference is that we now, change our quest, eternal quest in the science from, an equation that explains everything to search for even simple, AI models that possibly explain everything. If you want a model that explains everything, the model has to be big, large, or giant. So you can see that traditionally we use theory, we derive equations, we do numerical simulation or experiments to verify and validate the equations that we build. And right now we have data. Using data through machine learning, deep learning, we come up with the AI models. So what would be the new relationship between traditional theory and also, the equations with the AI models that we build? And another thing to consider is that if we back to, take a look at AI, is that currently the approach of AI is using the data from the past, and also through machine learning, you come up with a model, and the model could be implemented by, the artificial neural network, so that you can connect, the past, using the data from the past, connect now to the future. And that's exactly what we are doing right now. And so if you back to Newton's, you try to build a robot called Newton's. The point is that how many apples you need to hit the head of the robots in the order to create the theory of gravity. We don't know. So there are still rooms that we can develop, AI into different, applications. Another thing is that for large, models, you use the data from the past, and you try to create something, to create a new, a linkage from now to the future. The point is that everybody believes that, the Earth is the center, of the universe for, the 1400 years. You use the data to train the model. Can you come up with, Copernicus to allow people to, trust that sun is actually, the center of the galaxy that we live in? So there are many things that we need to consider for the future, especially how to carefully, deal with the data we collected. and how to understand the limitations of the model that we build. So we still have, the many things and challenges to do, heading for the future. And again, if you want to build models that can explain everything in respect to different kinds of prompts, the model has to be big, very big. And so you can see that, if you want to, build an AI for good things, for example, for sustainability purpose, you have to make sure that the AI is good enough. The AI has to be sustainable. So right now we are very focused on the applications and possibilities of AI, but the point is that can we make sure that we make a smaller, simple models that can do more things. Back to year 2000, I had questions with, at the time, the director of LCS, Professor Negroponte. I asked him one question: what is smart? People talking about smart, what is smart? He said, doing more by doing less. And right now we try to do more things, but there are many rooms that we have to do to simplify our design in the AI. And so you can see you need the big data so that you can generate big model, so that you can have more applications. But oftentimes, the application is quite narrow domain. So in some sense, we are over-design the model. And this is also the reason why hallucinations, that happens in the models, because nobody understands almost everything in our current systems. So you have to think about the data development and deployment into consideration. What's the cost? What's the outcome? So if you change the way we design, AI, if we only have a very small, the domain-specific applications, then the data set has to be small. Then the AI model has to be small as well. So this is a more, service-driven Gen AI approach, unlike, a big approach. So you can develop a big AI models, use RAG to do, model reduction, but you can also develop a smaller, scale of model directly. There's two ways of, Gen AI approach when you try to deploy the AI to real applications. So I just said that, in addition to building a big model, we are thinking about to build a set of small models. And you orchestrate, this just like, the orchestra. And you are not making a giant that can play all the instruments. You are making, different kinds of, instrument at the same time and make them play, the symphony. And so it's different, ideas, but the point is that how can we reduce the cost and to increase the performance of everything? So take human body, for example, and currently when we are talking about precision health, more and more people try to get the data from the human body, and they try to create a digital twin that we can possibly use the models to simulate your situation, your vital sign, your health conditions. But the model oftentimes is way too big. So another thing that we can do is that we think of your body just like a metaverse, and try to just to create a model for your organ first. So it's very the disease and organ driven applications, and that's our approach we are doing right now. And so, for example, for heart cardiology, you only need a small set of the sensors and data, and the models will be smaller. And so, of course, you can do more things about how to collect data, how to create metadata, and building the digital twins, visualize it, and to create a metaverse, and then you can do simulations before you use the real human body to test your new medicine. And another thing is that if we back to Gen AI, the most important thing is that we used to develop contents by human beings, just like Professor Liao. He is a professor. He writes articles. He creates very original, real contents. But right now, we try to use Gen AI as a different tools. You prompt Gen AI, you come up with synthetic content. But still, you need different kind of machine learning for that, and you try to create impacts for living lives, society, environment, and industry. And so, in the futures, it's also very important that when you prompt it, you have to develop certain kind of capability that you can verify and validate the outcome. If you don't have that kind of the capability, and that would be a problem. And another thing is that when more and more synthetic data existing in the real world, what will happen? We don't know. And that's another problems. I think in the afternoon, the professor from MIT, who was talking about how to use generative AI to generate more data and for AI purpose. And I think that is very important because in the future, you are not just dealing with real data, you also need to deal with synthetic data. So what can we do with generative AI? For application purpose, of course, you can, the productivity is very important, but also you can generate more products. And so for productivity, you can do more automations with AI. That's the part of what AI can do. And the other thing is that, of course, you can generate more contents as a new product and new services. So you can use the vital sign to generate the patient care, the therapy, and other things. But you also can use a different kind of data that using large multimodal models to create a digital twin for all kind of purpose. I only have 2 minutes, I understand. But basically, if you want to do that, for example, if you want to provision right care, right time, right place for anyone at any age, you need the infrastructure. And that infrastructure is actually what companies like Quanta can play, or Taiwan industry can play. But the most important thing is that we need more the innovators from startups to keep things moving. And so I'll skip this. So filling the holes and complete the codes is important. So if you don't understand, you are way too young for Jurassic Park 1, go back to the study Dr. DNA, you will know what I'm talking. And so, you can find, the new medicines. You also can generate, more designs. But I would like to spend 1 minute to talk about Quanta and MIT relationship. We developed our project with MIT since year 2004, actually. We kick off the projects, and this year will be our 20th anniversary. We're going to celebrate our collaboration with MIT. And so during the past 20 years, we have gone through different kind of, transformations and go through different kind of paradigm shift in the industry. And we also do many different crazy things. This is our first autonomous car back in year 2007. This is our telemedicine for the ambulance cars back in year 2009. And we are a little bit crazy, but we are both rainforest and hothouse. And the most important thing is that next month we're gonna celebrate our 20th, anniversary. And so there will be about 10 MIT professors in Taiwan again. And we will continue to discuss how we can work together. Thank you.